ನಮಗೆ
ಕಾಣಿಸ್ತಿದೆ, ರೆಕಾರ್ಡ್ ಆಗ್ತಿದೆ. ಸ್ಟಾರ್ಟ್ ಮಾಡು.
Good evening all. My topic for technical seminar is Artificial Intelligence Defined 5G Radio Access Network. I am guided by Professor Santosh sir. Today content for my presentation is Introduction, Literature Survey, Concepts, Procedure and Methodology, Applications and Case Study, Limitation, Conclusion and Reference. Before moving into the actual concept, we know the basic definition of artificial intelligence, fifth generation, and radio access network. Artificial intelligence is an area of computer science that emphasizes the creation of intelligent machines that work and react like humans. Fifth generation, that is 5G. 5G is the term used to describe the next generation of mobile network behind LTE mobile networks. Coming to the radio access network, it is the part of telecommunication system that connects individual device to other parts of network through radio connections. Coming to the introduction, the most widely used names in many research field nowadays is 5G. Fifth generation wireless is the latest iteration of cellular technology engineered to greatly increase the speed and responsiveness of wireless network. Massive multiple input, multiple output antenna system, millimeter wave communication, and ultra-dense network have been widely preserved as the three key enablers that facilitate the development and deployment of 5G system. Here there are many technical challenges in these three key enablers for development and deployment of 5G system. AI-based 5G radio access technology architecture is proposed for rapid deployment and flexible usage. This intelligent agent also combines sensing, learning, optimizing to facilitate these enablers, that is MIMO antenna system, millimeter wave communication, and ultra-dense network. Next, moving on to the literature survey I have done. The first paper is semi-defined relaxation-based PAPR aware precoding for massive multiple input, multiple output orthogonal frequency division multiplexing system. This paper proposed SDR means semi-defined relaxation-based method, which exploits the spatial degree of freedom. With this efficiently, the degree of freedom is used to yield a per antenna PAPR constrained OFDM signal. Next is cloud data center in the 5G era. This paper discusses a distributed full stack cloud data center that is open, flexible, and intelligent cloud infrastructure, which is able to meet the network and service requirements of 5G. Next paper is a survey on 5G mobile technology. This paper gives the comprehensive analysis of improvements in 5G mobile communication. Here it highlights the silent features such as flexibility, accessibility, higher bandwidth, etc. to make the 5G technology as the most dominant technology. Next is 5G ultra-dense cellular network. In this paper, a distributed network architecture with single and multiple gateways are presented for 5G ultra-dense cellular network and also provide some guidelines for the optimum deployment of 5G ultra-dense network. Next, moving on to the concept, this is not actually my content, but to gain some basic knowledge, I have included this. Here in first generation, it is the analog signal system. It is developed in 1980s and completed in early 1990s. Here the speed is up to 5 kilobytes per second. In first generation, it allows user to make voice call in one country only. Coming to the second generation, it is developed late in 1980s and completed in late 1990s. It is based on digital system. Its speed is up to 64 kilobytes per second. Services such as digital voice and SMS with more clarity. Here, 2G are the handset which some of us we are using today, with the 2.5G having more capabilities. Coming to the third generation, this is the phase where drastic change took place. It developed between late 1990s and 2000 until present day. Transmission speed is up to from 125 kilobytes per second to 2 megabytes per second. Superior voice quality, good clarity in video conference, and fast communication. And also email, PDA, information suffering on line shopping, banking, etc. are included in 3G. Coming to the fourth generation, it is slight increase in speed, and it is developed in 2010, faster and more reliable, speed up to 100 megabytes per second, both cellular and broadband multimedia services everywhere, and high performance when compared to 3G, easy global roaming and low cost. Coming to the fifth generation, 5G technology will change the means to use cell phone within very high bandwidth. The 5G technology will include all type of advanced features which make 5G technology most powerful and huge demand. 5G technology include camera, MP3 recording, video player, and etc. It is the next major phase of mobile telecommunication and wireless system. Maybe it will be 100 times faster than the 4G. Expected speed is up to 1 gigabytes per second. It will be more faster than 4G. Next, coming to my actual topic, that is usage scenario. 5G network are anticipated to achieve system capability improvements through aggressively increased spectral efficiency and channel bandwidth and higher densification. The International Telecommunication Union classifies 5G into three categories of usage scenario. You can see it in the figure. First one is enhanced mobile bandwidth. It emphasizes high bandwidth and high throughput of the network with high rates. That is, it is more than 10 gigabytes per second. Enhanced mobile bandwidth is a service category that addresses bandwidth-hungry applications such as massive video streaming and virtual augmented reality. Next is massive machine type communication. It is also known as M2M communication. It enables direct communication among electronic devices. Massive machine type communication is a service category enabling massive sensing, monitoring, and measuring in support of massive deployment of Internet of Things. Ultra reliable and low latency communication. It can be defined as the set of features that provide low latency and high reliability for critical applications. It provides a service category that supports sensitive services including autonomous driving, drones, and other applications. AI seems to offer virtually any services. The importance of cognitive resource management cannot be underestimated, and AI-defined 5G radio access network are proposed to support those unpredicted requirements and leverage the emergence of mobile edge computing and caching, smart cities, and context-aware network. Next, coming to the application scenario. Recent discovery in computing and AI have encouraged research in the field of wireless communication to leverage AI, especially in the 5G content, which is illustrated in figure. An AI-defined 5G network provides the base stations or cloud with the ability to create a cognitive and comprehensive data repository by splitting, processing, and interpreting the operational data. As we know, massive amounts of real-time data are generated across a large number of users and ranges from channel state information to IoT device reading. The received data and geolocation databases are fused to derive a complete understanding of the environment. From the human-centric communication, human-centric communication means merging data company access in customers and employees, etc. The human behavior are learned and adopted by the reconfigurable AI-defined wireless network to evolve the network functionalities and create people-oriented service. From the machine-centric communication perspective, big data analytics and leverage to extract massive patterns, especially at the physical and MAC layer, as I shown in the figure here, the physical layer and the back layer, and enable self-organizing operation. I explained this. Hello?
ದೇವಿಕಾ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್.
ಆಕ್ಚುಲಿ ನೀವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನಿಮ್ಗೆ ನೀವು ಪಾಯಿಂಟರ್ ಅಥವಾ ಮಾರ್ಕರ್ ಯೂಸ್ ಮಾಡಕ್ಕಾಗಲ್ಲ ಸ್ಕ್ರೀನ್ ಮೇಲೆ. ಯಾಕಂದ್ರೆ ನೀವು ಡಿಸ್ಪ್ಲೇ ಮಾಡ್ತಾ ಇರೋ ಸ್ಲೈಡ್ ಡಯಾಗ್ರಾಮ್ ಡಿಸ್ಪ್ಲೇ ಮಾಡಿ, ಬಟ್ ನಿಮ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ನಾವ್ ಎಲ್ಲಿ ನೋಡ್ಬೇಕು, ಯಾವ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ನೀವು ಮಾಡ್ತಾ ಇದೀರಾ ಅಂತ ನಮ್ಗೆ ಹುಡುಕಕ್ಕೆ ಟೈಮ್ ಆಗ್ತದೆ.
ಸರ್ ನಾನು ಮೌಸ್ ಮೂವ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಸರ್, ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಅನ್ಸುತ್ತೆ.
ಇಲ್ಲ ದೇವಿಕಾ, ಒಂದ್ ಕೆಲಸ ಮಾಡಿ, ರೈಟ್ ಕ್ಲಿಕ್ ಮಾಡಿ, ಅಲ್ಲಿ ಪಾಯಿಂಟರ್ ಅಂತ ಇರ್ತದೆ ನೋಡಿ. ಅಲ್ಲ, ರೈಟ್ ಕ್ಲಿಕ್ ಮಾಡಿ, ಒಂದು ಪಾಯಿಂಟರ್ ಅಂತ ಬರ್ತದೆ. ಅಲ್ಲಿ ಪಾಯಿಂಟರ್ ಹೋಗಿ ಅದ್ರೊಳಗೆ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಪೆನ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಬರಿಬಹುದು ನೀವು.
ಬಾಲ್ ಪಾಯಿಂಟ್ ಪೆನ್.
ಅದನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಬರಿಬಹುದು. ನೀವು ಸರ್ಕಲ್ ಮಾಡಿ, ಏನ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಿರ್ತಿರೋ ಅದನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಸರ್ಕಲ್ ಮಾಡಿ ಅದನ್ನ.
The complexity of 5G content and the power of AI allow rethinking cellular communication. This
Hello, Devika.
ಇಲ್ಲಿ ಬರೆಯಕ್ ಆಗ್ತಾ ಇಲ್ಲ ಸರ್, ಇದು ಬರೆಯಕ್ ಆಗ್ತಾ ಇಲ್ಲ ಸರ್.
ಲಾಂಗ್ ಪ್ರೆಸ್ ಮಾಡಿ ನೋಡು.
ದೇವಿಕಾ, ಒಂದ್ಸಲ ಕ್ಲಿಕ್ ಮಾಡಿ ಡ್ರ್ಯಾಗ್ ಮಾಡಿ, ಅವಾಗ ಬರೆಯುತ್ತೆ ಅದು. ನೀವು ಸುಮ್ನೆ ಮೂವ್ ಮಾಡಿದ್ರೆ ಬರೆಯಲ್ಲ. ಬಂತಲ್ವಾ?
ಸರ್.
ಇವಾಗ ಬರೀರಿ, ಚೆಕ್ ಮಾಡ್ಬೇಕು, ಆಯ್ತಾ? ಸರಿ, ಮಾಡಿ ಮಾಡಿ.
This here 5G use cases, URLL, MMTC, EMVB are 5G use case, and these are 5G technology enabled, that is massive MIMO, mmWave, ultradense, and this is the neural networks which will be helpful for the enablers. Here neural networks can be used to redefine communication networks, solving a number of non-trivial decision problems at runtime and across layer for adoption, signal classification, sensing, collision detection, among others. This This RNN has the capability to capture and mitigate the imperfection and non-linearity of RF components such as high power amplifiers, which are at physical layer and can affect the network performance. So it is useful in overcome the challenges in massive MIMO. And DBN and CNN are better suited for resolving a range of upper communication layer tasks such as network optimization and resource management. So it will be helpful in massive MIMO, as CNN is helpful in massive MIMO and wave. DBM is helpful in wave and ultra dense network. Next. Now let we discuss some emerging physical and MAC layer issues of 5G network and propose AI-based 5G radio access technology architecture. Coming to the technical challenges of 5G, massive multiple input and multiple output. It can be defined as an antenna technology for wireless communication in which multiple antennas are used at both source and destination. Multiple input, multiple output is widely preserved as a leading candidate technology for 5G. The high number of base station antennas requires a large number of power amplifiers, that is one per antenna. The primary problem in RFPAs is known as the design trade-off between linearity and efficiency. Here, amplifiers can be designed to attain good linearity at the cost of efficiency, while high linear power amplifiers are expensive and power inefficient. The excessive number of base station antennas make use of inexpensive components, desirable to keep the overall capital expenditure and operational expenditure manageable. On the other hand, wireless communication is vulnerable to non-linear distortion that are attributed to RF front-end, especially those of high power amplifiers, which affect the performance of the receiver and the entire network. Next generation communication system will in more dynamic environment and in different bands. Therefore, the power amplifiers need to meet stricter linearity specification while maintaining acceptable efficiency. To overcome this challenge, here I have two solutions. The highest PA efficiency is achieved when constantly feeding the power amplifier at the limit of its highest power linear region. This is not a feasible solution since we cannot constantly feed for high peak to average power ratio signals, and it is not realistic for 5G base station also. Instead,
ಆಮೇಲೆ ನಂಬರು ಅಲ್ಲಿ
I have came up with a feasible solution, that is signal processing based solution are used to provide a better cost performance trade-off. One of the main advantages of RNN is their ability to extract, predict, and categorize non-linearistics for massive data set. RNN means recurrent neural network. It is well suitable to tackle non-linearity problems at the physical layer, including power amplifiers, non-linearity tracking, predictions, and impairments correction. Coming to the methodology, technique have been invested for wireless communication system to efficiently mitigate non-linearity at the physical layer.
ಎಷ್ಟು ದೂರದಿಂದ ನೋಡಿ ಕಂಡಿಡಿದ್ರೆ ಅವರೇ ಅಂದ್ರೆ ಅವಳೇ
In particular, RNAs lend themselves to address RF nonlinearity issues because they allow historical information to be stored through loop-based structure. RNA are capable of automatically extracting nonlinear system features that are invariant to environment and can outperform traditional approaches in physical layer signal processing. As I told earlier, energy efficiency of a base station significantly depend on power amplifier efficiency. The deployment of massive multiple input, multiple output system where base station are equipped with a significantly larger number of antennas than the number of simultaneous served users is known. The excessive degree of freedom enables selecting the transmit signals from a larger solution space. Energy efficient beam forcing is a massive multiple input multiple output system is then to find the beam forcing matrix. Beam forcing matrix is nothing but a three-dimensional matrix of transmit and one is transmit antenna, space time stream, and subcarriers, which introduce minimum PA nonlinearities within this solution space. This enables the use of low-cost PAs and their operation. Zero forcing beamforming is applied and user information
Hello, Devika. Hello, Devika.
ಸಿಗ್ನಲ್ ಬ್ರೇಕ್ ಆಗಿರ್ಬೇಕು.
ಸರ್ ಇನ್ 10 minutes ಇದೆ ಈ ಸೆಷನ್.
ಸಿಗ್ನಲ್ ಬ್ರೇಕ್ ಆಗಿದೆ ಅವ್ರದ್ದು.
ಹಲೋ ದೇವಿಕಾ. ಹಲೋ
ಹಲೋ
ಹೇಳಿ ಇವಾಗ. ನೆಟ್ವರ್ಕ್ ಬ್ರೇಕ್ ಆಗಿತ್ತು ಅನ್ಸುತ್ತೆ, ಹೇಳಿ ಇವಾಗ.
ಓಕೆ. ಸ್ಕ್ರೀನ್
ಆಯ್ತು ದೇವಿಕಾ ಅವ್ರದ್ದು.
ಇನ್ನ ಅವಳದು ಒಂದು 10 slides ಇದೆ.
10 slides ಇದೆಯಾ?
ಹಾ ಸರ್.
ಸ್ಟಾರ್ಟ್ ಆಗಿ ಎಷ್ಟು ಮಿನಿಟ್ಸ್ ಆಯ್ತು?
ಸರ್ ಸ್ಟಾರ್ಟ್ ಆಗಿ 20 minutes ಆಯ್ತು ಸರ್.
10 minutes ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇನ್ನೂ ಇರ್ಬೇಕಲ್ಲ 20 minutes.
ಸರ್ ಇನ್ 10 minutes ಇದೆ ಅಷ್ಟೇ ಸರ್. ಅಂದ್ರೆ ಜಾಯಿನ್ ಆಗೋದು ಲೇಟ್ ಆಯ್ತು.
ಸರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ.
ಕಂಟಿನ್ಯೂ ಮಾಡಿ ಬೇಗ. ಇನ್ನು
Here an RNN-based solution is inspired by the similarity between the beam forcing power amplifier architecture in multi-user, multiple input, multiple output system and the neuron activation function as you can see in this figure. The neuron weights training behind this solution is like the nonlinear activation function in the RNN learns about the nonlinearistics of the PAs recursively and finds suitable neuron weights that satisfy two requirements, that is a zero forcing beam forming, which means minimal multi-user interface.
ಹಲೋ ದೇವಿಕಾ. ದೇವಿಕಾ
ಸಂತೋಷ್ ಸರ್ ಕಂಕ್ಲೂಡ್ ಮಾಡಕ್ ಹೇಳಿ ಸರ್, ಟೈಮ್ ಆಗ್ತಾ ಇದೆ ಅಲ್ವಾ, 5 ನಿಮಿಷ ಇದೆ.
ಈಗ ಕಂಕ್ಲೂಡ್ ಮಾಡಿ. ಸೊ
Sir,
ಮೋಸ್ಟ್ಲಿ
ಅವ್ರು-
ಅವ್ರಿಗೆ ಸಿಗ್ನಲ್ ಪ್ರಾಬ್ಲಮ್
ಸರ್ ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಸರ್ ಅವಳಿಗೆ.
ಹ್ಞೂ ಸರ್, ಅದು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಅದು ಆಬ್ವಿಯಸ್. ಕಂಕ್ಲೂಡ್ ಮಾಡಕ್ ಹೇಳಿ ಸರ್, ನೋಡೋಣ.
ಇಲ್ಲ ಆಕ್ಚುಲಿ ಅವಳು ಹುಡುಗಿ ಬೆಳಗ್ಗೆ ಹೇಳಿದ್ದು ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಅಂತ, ನಾನ್ ಟ್ರೈ ಮಾಡೋ ಅಂತ ಹೇಳಿದೆ ಆಕ್ಚುಲಿ ಅವ್ರಿಗೆ.
ಇಲ್ಲ ಅವ್ರ ಎಫರ್ಟ್ ಕಾಣ್ತಾ ಇದೆ ಆಲ್ರೆಡಿ ಸ್ಲೈಡ್ಸ್ ಅಲ್ಲಿ, ಅವ್ರ ಸೆಷನ್ ಅಲ್ಲಿ. ಸೊ ವಿ ಕ್ಯಾನ್ ಗೋ ಅಹೆಡ್ ವಿತ್ ಕನ್ಕ್ಲೂಷನ್.
ಕಂಕ್ಲೂಡ್ ಮಾಡಿ, ಕೇಳಿಸ್ತಾ ಇದ್ರ?
ಸರ್ ಒಳಗೆ ಅದು ಕೇಳಿಸ್ತಿಲ್ಲ ಅನ್ಸುತ್ತೆ ಸರ್. ದೇವಿಕಾ
ಯಾವ್ದೋ ಬೂತ್ ಬಂಗ್ಲಿ ಹೋಗ್ಬಿಟ್ಟು ಹೆಸರು ಕೂದಂಗ್ ಆಯ್ತು. ಒಬ್ರು ಕಣ್ಗೆ ಒಬ್ರು ಕಾಣ್ತಾ ಇಲ್ಲ.
ಹೋಸ್ಟ್ ಯಾರು?
ನಾನು ಸರ್.
ಅಶ್ವಿನಿ, ನೀವು ಅವ್ರಿಗೆ ಫೋನ್ ಮಾಡಿ ಹೇಳ್ಬಿಡಿ, ದೇವಿಕಾ ಅವ್ರಿಗೆ.
ಕಾಲ್ ಮಾಡಿ. ದೇವಿಕಾ, ಹಲೋ. ಏನು ಕೇಳಿಸ್ತಿಲ್ಲ. ಕನ್ಕ್ಲೂಡ್ ಮಾಡ್ಬೇಕಂತೆ, ಕನ್ಕ್ಲೂಡ್ ಮಾಡು.
ಈಗ ಕೇಳಿಸ್ತಾ ಇದ್ಯಾ?
ಇವಾಗ ಕೇಳಿಸ್ತಿದೆ.
ಹಾ ದೇವಿಕಾ, ಕಂಕ್ಲೂಡ್.
IoT
ಇನ್ನೂ
ಮತ್ತೆ
ತುಂಬಾ
BDS
slides
ಸೆಮಿನಾರ್
ಇದೆ
ಮಾಡ್ಬೇಕಾದ್ರೆ
sir.
ಹಿಂಗೆ ಇತ್ತು. ಹಲೋ ದೇವಿಕಾ.
ಇನ್ನೂ ತುಂಬಾ
ಸಂತೋಷ್
slides
sir.
ಇದೆ ಸರ್.
ಹೇಳಿ ಮ್ಯಾಮ್.
ಸರ್ ಹೋಗ್ಲಿ ಬಿಡಿ, ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ.
ಓಕೆ ಮ್ಯಾಮ್, ಓಕೆ. ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಕಳ್ಸ್ತಾ ಬಿಡಿ ಇವರು.
ಓಕೆ.
ಓಕೆ.
ನೆಕ್ಸ್ಟ್ ಸೆಕ್ಷನ್ ಅಶ್ವಿನಿ ಕಳಿಸ್ತೀಯ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್?
ನೆಕ್ಸ್ಟ್ ಯಾರು
ಧನುಷ್.
ನೆಕ್ಸ್ಟ್ ಮಾಡ್ತಾರೆ ಅದು ಲಿಂಕ್ ಮತ್ತೆ ವಿಶೇಷ ಸರ್ಗೆ ಮತ್ತೆ ಲಿಂಕ್ ಕಳ್ಸ್ಬಿಡಿ ಮ್ಯಾಮ್ಗೆ.
ಸರ್ ನೀವು
ಇದನ್ನ ಎಂಡ್ ಮಾಡ್ಬಿಡಿ, ಸೆಷನ್ ಎಂಡ್ ಮಾಡ್ಬಿಟ್ಟು ಇನ್ನೊಂದು ಸೆಷನ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ಬಿಟ್ಟು ಸರ್ಗೂ ಮತ್ತೆ ಮ್ಯಾಮ್ಗೂ ಕಳ್ಸಿ.
ಸರ್ ಕ್ರಿಯೇಟ್ ಆಗಿದೆ, ಕಳ್ಸಿಲ್ವಾ ನೀನಿನ್ನು?
ನಾನು ಇವಾಗ ಕಳಿಸ್ತಾ ಇದೀನಿ, ನೀನೇ ಹೋಸ್ಟ್ ಮಾಡ್ಬೇಕು.
ಮುಗಿಯುತ್ತಲ್ಲ ಇವಾಗ 40 ಮಿನಿಟ್ಸ್.
ಅಲ್ಲ ಸರ್ ಕ್ರಿಯೇಟ್ ಮಾಡಾಗಿದೆ.